The owner of, determine the null and the alternative hypothesis. The owner of a football team claims that the average attendance at the game is over 81,000. And he is therefore justified in moving the team to a city with a larger stadium. Okay, take a minute, write down the null and the alternative hypothesis, and we'll discuss in a minute. You should be able to do that. Okay, so let me put the null and the alternative hypothesis. Mean. He says is more than over 81,000. So that should go to the alternative. This is where the claim. And that should be less than or equal to 81,000. Number 2, guys. That's a hypothesis. In a sample of 88 adults selected randomly from one town, it was found that 6 of them have been exposed to a particular strain of the flu. So that sounds like a proportion. At the 0.01 significance level, test the claim that the proportion of all adults in the town that have been exposed to this strain of the flu differs from the nationwide percentage of 80%. Okay, so you agree this is a proportion test. So you're gonna use one prop Z test. Okay, I'm gonna give you a couple minutes to start this one, and then we'll go over the solution. You can see N is 88 here, and X is 6, and alpha is 0.01. And you need to check if the proportion is different from 8%. Why don't you guys try it out for a couple minutes, and we'll resume in a couple minutes. So I'll wait for you until you get some work done. Okay, let's do this problem. So guys, it's gonna be HO and HA. P, it's a proportion. It says a percent here. No mean, no standard deviation, so it is a proportion. Okay, he says different from 80%, so the difference should go here, 0.08, and the equal should be there. And now it's a prop Z test. N is 88, X is 6, and alpha is 0.01. Okay, let's do it. Technology now. So that's section 7.4, guys. You go to stat. Let me just show you the keys again. Stat, tests, one prop Z test, 0.08 here, 80% is 0.08, be careful. 88, then 6, then different from, and then hit calculate. Oops, what did I do here? Let me try again. One prop Z test, X, oh, X is 6, I'm sorry. N is 88, that's a mistake. X is a smaller number and N is a bigger number. And then that's why the calculator produced an error. Now it should work. Okay, so I got Z to be negative 0.41, and the p-value is 0.6828. And can you guys tell me what the decision is? Someone can type it. Do we reject HO or fail to reject HO? Good. Everybody is saying fail to reject HO, and I agree. And I forgot to mention the claim right here. Okay. If you fail to reject HO, guy, and your claim is in HA, then you cannot support the claim. So you say there is not enough evidence at the 0.01 level of significance to support the claim. And what is the claim? That the proportion of all adults in the town that have been exposed to this strain is different from 80%. That the proportion, you write it down, just copy and paste whatever is written in the claim, that the proportion is different from 80%. That concludes this problem, guys. Okay, the next one. Okay, I'd like you to read it. Let's read it, make sure we understand what to do, and I'm gonna let you do this one. All right. A manufacturer considers his production process to be out of control when defect exceed 3%. Can someone tell me what does exceed mean in terms of inequality signs? That's very important. You have to understand that. Yes, Ryan says more than, greater than, I agree. Asma, greater than, yeah. So that's what we need to test probably. In a random sample of 800 items, so N is 800. So you can see, guys, it's a proportion. I'm doing backward. I'm starting with section 7.4 today. X is 42. 42 of the items were defected, which is a little more than 3%. The manager claims that this is only a sample fluctuation and production is not really out of control. At the 0.01 level of significance, do the data provide sufficient evidence that the percentage of defects exceeds 3%? Okay, just so alpha is 0.01, very much similar to the problem before. HA, and would you guys, what do you think that the alternative hypothesis sign should be here? I'll wait for, it says exceeds, so just can you someone type it? More than, okay. And guys, don't write 3, it's a 3%, so you have to change it to a decimal. Okay, I'll give you a minute or two to finish this exercise. So run the prop Z test and okay, I'm gonna do it in front of you guys. I didn't put anything in the calculator yet. So you go to stat, tests, one prop Z test. We're testing against 0.03. X is the smaller number. Again, don't make this mistake, make it the larger one. N is 800. And we need to test that the proportion is greater. That's the alternative sign. And then hit calculate. And Z is 3.73, that is correct. And P is, I'm gonna write it down and show you how to interpret that. That's very important. So, and look what the p-value is, guys. That's what I got off the calculator, but let's interpret that. That means it's almost 0, because it means -5, you have to move the decimal 5 places. So it's gonna be 0.00009, which is definitely less than alpha, and then you end up what? Rejecting HO. Okay, if you reject HO, and now what is the claim? The claim is right here. So you support the claim because the first one is not good, the second one must be good, and the claim happened to be there, so you support the claim. So you say, there is enough evidence at the 0.01 level of significance to support the claim that, and you just copy it, that the percentage of defects exceeds 3%. So the manager was wrong. He didn't think so. All right, guys. So that number 3. Let's go to number 4 now. Does a majority or a minority of American workers think that they have a healthy balance between work or personal life? Okay. This is kind of slightly different from what it's still a proportion. What does majority? So let's test the majority, for example. If you want to test the majority, if I ask you this question, I would say, does a majority of, so let's remove or a minority, I'm just going to put the majority of American workers think that they have a healthy balance between work and personal life. Can you guys type in the null and the alternative hypothesis and see what you come up with? Majority, we discussed that last time. If you see that word, what does it mean? What is it that you need to test? Yes, more than 50%. More, I guess, yeah, more than 50%. So look, guys. That's what you need to test. All right. A poll of 1626 workers by online job board True Careers reported. So what's 1626? Can someone tell me what's 1626? It's either N or X. N, I agree. Reported that 70% don't think that there is a healthy balance. Oh, now we need X. How am I going to find what is X, guys? Can someone tell me what X is? This is what I'm getting from students. I'm getting from students it's 70%. Well, X, it has to be a whole number. Yes, it is 70%, but 70% of N. So this is how different this exercise is. It is different from other exercises. I didn't give you X directly. I gave you a percentage of the sample. So look what you do to find X. You just do 0.70 times 1626. Let's multiply and see what we get. Clear here. Okay, you see the answer that I got, guys? I got 1138.2. Okay, 1138.2, but X has to be a whole number, guys. It's a number of successes. So you round this number to the nearest whole number. So it is 1138. I'm going to use 1138. If you put in your calculator 1138.2, it will not do it. So it's 1138. And it's a proportion Z test. So again, anytime you get a value of X, if it's a decimal, you must round it to the nearest number. So it's 1138. Okay, let's run the test now together. So stat, I'm gonna go to stat, tests, one prop Z test, and it's 0.5 for P0, enter 0.5 for P0, X is 1138, N is 1626, and we need to tell the alternative to be greater than. So under a prop, go to the third one and select that one and hit calculate. If you're doing that in your calculator, you should get Z equals 16.12. Oh, it's a huge. When Z is very large, then the p-value will be very small. P is 9.82, E negative 59. So would you guys agree with me that you have to move the decimal point 59 digits, so just put 0. I'll just put 0 here. And then it's less than alpha for sure, so you end up rejecting HO. And yes, if you reject HO, guys, and the claim is in H, the alternative hypothesis, you support the claim. So you say there is enough evidence at the 0.0, at the 0.10 level of significance to support the claim that majority of American workers, I'll write it down, think don't think that they have a balance between work and health. There you go. Yep, I agree with what you stated there. If you reject HO and the claim is in HA, you support the claim, guys. That's how it works. Again, I will share this with you later. I'll scan them and send them to you. So let's go to the next one. Number 5. Number 5, guys, you don't need to do any work. You just tell me what the answer is. It's a multiple choice. The test statistic for testing HO mu equals 100 against HA mu not equal was T 3.3 and the p-value is 0.001. He didn't give you alpha here, but I told you guys, if he doesn't give you alpha, assume it's 0.05. Then, which one would you choose? Is it A, B, C, D, or E? Compare the p-value with alpha. Let's see what students, yeah, somebody is asking me if we use 50% for majority. Yes, either majority or minority. Majority more than 50%, minority less than 50%. Yes. So which one You guys would agree with what the p-value is. There is okay. Let's see if it is C. Yeah, we reject HO. That means we don't have enough evidence that actually mu equals 100. I agree, because when the p-value is less than alpha, we reject HO. That means HO is bad, and C says HO is bad. We don't have evidence for it. P-value less than alpha, reject HO. That's it. All right, let's go to the next one. Now testing the mean. Assume that the simple random sample has been selected from a normally distributed population. State the final conclusion. Test the claim that the mean lifetime of car engines of a particular type is greater than 220,000 miles. Sample are summarized as N is 23, X bar is 226 for 50 miles, and S, I gave you S here, guys, so you know it's not a Z test, it's a T test. Use a significance level alpha of 0.01. So it's a T test. I'm gonna give you about 3 minutes to write it down and just put it in your calculator. Okay, let's do it together. So for number 6, test the claim that the mean lifetime of a car engines of particular type is greater than 220,000. So you guys agree with me that the mean is greater than 220,000. That's the claim. And the mean is less than 220,000 or equal to, it's the null hypothesis. And we got that data summary. So it's a T test. You guys agree it's a T test? Okay, let's perform a T test and I'll walk you through the steps. So you go to stat, tests, T test, select T test. Input, you choose stats because it's a summary. Mu 0, you put 220,000. X bar, whatever X bar is given, 226450. S, 11,500. And N is 23. Then the last step before you hit calculate is to choose the alternative hypothesis, which is greater than here. And hit calculate or draw, either one is good. So I got T to be 2.6869, 2.690. And the p-value, guys, turns out to be 0.0067. And that's what I have. And the p-value, what's alpha? 0.01. I think it is less than alpha. So we end up what? Rejecting HO, the null hypothesis. And if we reject the null hypothesis and the claim is in the alternative, we support the claim. As simple as that. There is enough evidence at the 0.01 level of significance to support the claim that the mean life, I'm just copying and pasting, guys. I'm not making anything up. Lifetime of car engines of a particular type is more than 220,000 miles. Any questions? I hope that the stuff is making sense to you guys. I see 0.269. Did I get to 0.269? It should be 2.69 to my best. You guys, you must probably have missed the zero or something like that, but it should be 2.69. Okay, good. I see students made some mistakes in the data entry, but this is how it is. Okay, let's go to the next one. Number 7. At one school, the average amount of time that ninth graders spend watching television each week is 21.6 hours. The principal introduces a campaign to encourage the students to watch less TV. 1 year later, the principal wants to perform a significance test to determine whether the average amount of time spent watching television per week has decreased from the previous mean of 21.6. Can you guys write the null and the alternative hypotheses? It says he wants to check if the mean has decreased from the previous one, which is 21.6. So what do you think, guys, I should put there? Let me see what you think. Yes, less than. This is the claim. And greater than or equal, it's the total opposite. All right. He surveyed 23 students. So N is 23. And obtain a sample mean of 20.4 with a standard deviation. He didn't say population standard deviation. It's the same sentence of the sample, so it must be S, 2.3 hours. And he says use alpha equals 0.05. So you guys, this tells you that this is a t-test. Okay, let's perform this t-test together and see what we get. All right, so I'll go to my calculator, stat, tests, t-test. So you go to stat, t-test, and then mu0, you must change that to 21.6. X bar is 20.4. S is 2.3. N, how many students? 23. And now the alternative sign, it should be a less than. And then hit calculate. And if you do this, guys, you're gonna get T to be negative 2.502 and p-value is 0.0101. So negative 2.502. And my p-value is 0.0101. We're testing against 5%, so you guys agree this is less than alpha, so we end up what? Rejecting HO. And if you want to justify why you're rejecting HO, because the p-value is less than alpha. Your conclusion. Oh, we're supporting the claim today in most of the problems. We reject HO and the claim happened to be in HA, the alternative, we support the claim. There is enough evidence at the 0.05 level of significance to support the claim that the average amount of time spent watching television per week has decreased from the previous mean of 21.6 hours. So just write it down here. Let me just make sure you see it. And that's what number 7 is about. For the next question, guys, let's do the next question. Again, so this is the second one we do with t-test. The third one, let's see if it is a t-test or not. In the past, the mean running time for a certain type of flashlight battery has been 9.3 hours. The manufacturer has introduced a change in the production method and wants to perform a significance test to determine whether the mean running time has changed as a result. Okay, guys, take a minute and tell me what would be the null and the alternative hypothesis in this case. So number 8, again, let me just repeat. So the null hypothesis mu equals 9.3. The alternative mu not equal to 9.3, and we got the summary of the data from the question. It's a t-test. So for S we enter 2.3, for N we enter 25, and for the alternative sign before we start hitting calculate, it's not equal to, that's the sign in there, and then if you do calculate, guys, you're going to get T to be negative 1.087 and the p-value to be 0.2879, 4 decimal places. So T is negative 1.087 and the p-value, just be very careful, especially when you do your work on my math lab, because it's very picky when it comes to rounding. So just follow directions. All right, so let's see here what we have. And you guys agree with me that this is more than alpha, which is 0.05. Oh, good. Now we're failing to reject HO this time. We failed to reject HO. If you guys fail to reject the null hypothesis and your claim is in the alternative, then you say, I cannot support the claim. You're right. There is not enough or sufficient evidence. Some books use the word sufficient instead of enough. So enough evidence at the 0.05 level of significance to support the claim that, and I'll just get it from the question itself, that the mean is different from 9.3. Or you just can cut and paste whatever the claim is when you write it down. So this is number 8. Let me go to number 9. And now before I do anything in number 9, guys, I'm gonna give you a couple minutes to key in the data because it has a data set in it. Oh, I'm saying some students got some different answers. So let's make sure that we agree on that one. Okay. So you go to stat, tests, t-test, probably was wrong somewhere. Let me see. So you put the mu0 is 9.3. And then X bar is 8.8. That's what I have. And then the standard deviation, oh, I made a mistake. It's 1.8. I put 2.3. I don't know why. So you're right. And is 25. Yeah. Where did I write that? Oh, I got it from the previous question. So yeah, let's change that. Calculate. And yes, let me change them. It's not going to change the outcome, but yes, the values do change. So that will be negative 1.3889 You were correct. And the p-value would be 0.1776. Yeah, I agree. Okay. So again, I did enter the wrong standard deviation, guys, from the previous question. For number 9, first of all, I'd like you to key in the data in L1 before we do anything. So let's do it in L1. I'll give you a couple minutes, and then we proceed with this one. All right, let's do this one. Local school district claims that the number of school days missed by a teacher due to illness is below the national average of 5. A random sample of 24 teachers provided the data below. At alpha equals 0.05, test the district's claim. So you guys, we need to test that the average is below the national average of 5. That's what the school is claiming. That's their claim. They're saying that their teachers don't miss days, and if they miss, it's less than 5 days. That's a good claim. Okay, we need to test this one. So it's a t-test. And let's go. I already put my data into L1. So I'm going to go to the calculator, stat, tests. Now, guys, I'm going to go to t-test. And I'm going to change input to data, because now your input is from data. You have a raw data set. So you change that to data. And then mu0 is a number 5. We're testing against 5. My list is in L1. If you put it in another list, guys, it's okay. You can change that, no problem. Just put second and whatever number. Frequency, I told you the other day, don't change it, and it's less than here. Calculate. Okay, I got T to be negative 3.2096. If you round it, it will be negative 3.21. And the p-value, guys, is 0.0019. And what would be the decision in this case here? Alpha is 0.05. Can you tell me, guys, what do you think the decision will be? Reject HO, yes. Reject HO. Because p-value is less than alpha. Remember, guys, the acronym. P-value low, HO must go. So this is low, then HO must go. It means you reject it. When you say something must go, then you reject that something. And then you write, there is enough evidence at the 0.05 level of significance to support the school district claim that number of school days, it's an average, missed by their teachers, is less than 5. Or is below the national average. There you go. Again, guys, I will scan this and email it to you later today, so you can have a copy, finished copy of the problems as well. Any questions? No questions, all right. Oh, somebody asked me, how do we decide it's a t-test? It is a t-test because he give you, first of all, a raw data set, and he didn't give you the population standard deviation. If you guys doesn't give you the population standard deviation, feel free to use the t-test. It's going to be the t-test. So most of the, we haven't done the z-test yet, so probably it's toward the end. No, the claim is not. Somebody is asking me why the claim is not an HO. It says below the national average. Below means less than. That's what below means. What I want to try to do also, I'm going to come up with a list of words, guys, and then just put them all together and send them to you with the sign that you should use on each one. So every time you see the word below, it's a less than, above, more than, and so on and so forth. Oh, somebody is asking me about number 8, why it wasn't an HO. Yes, they started and say is 9.3 hours, but the one who's doing the question, he says, the one who's asking the question is asking whether the mean running time has changed. So this is what the question, you follow the question, you don't follow what they say at the beginning. It's whatever the claim is. The claim is someone want to check if this has changed. That means it's not the same. Good question. Number 10, guys. I will give you also a chance to enter, so take a minute to enter the data in there. A local group claims that the police issue more than 60 speeding tickets in a day in their area. To prove their point, they randomly select 2 weeks. Their research yields the number of tickets issued for each day. The data are listed below. Test the claim. So more than, guys, it's going to be, I'm going to do it right here, number 10. It's obvious that more than, it's going to be mean is more than 60. That's the claim. And your null hypothesis is less than or equal to 60. Again, it's a t-test. I put my data in L2. So this, my data went to L2 here. You don't have to put it in L2, but I did. So let's run the test. Stat. Tests. T-test, guys, again. Data, your input is data now. Mu 0, you're testing against the value 60. That's the value from the null hypothesis. As we say, we assume the null hypothesis is true until proven otherwise. I'm going to change my L1 to L2, so I press second and number 2. Frequency is 1. And then what is the alternative? The alternative is greater than. And then I'm going to do a draw this time. Let's do a draw. Takes a little bit of time. Oh, it looks like the p-value is big. So I got t to be 0.0597. If you get any different answers, guys, let me know. And I got p to be 0.4766. Yes, I put 60 for mu 0 because we need to check if it is more than 60, yeah. So that's what I got. And the p-value, guys, is more than alpha, so we fail to reject HO. No claims has been in HO yet so far. I didn't intend that, but this is how it worked. So fail to reject HO. Since we fail to reject HO, we cannot support the claim. So you say there is not enough evidence at the 0.05 or 0.01 level of significance to support the local group claim that more than 60 speeding tickets are, I'll show it to you here, more than 60 speeding tickets are issued a day in their area. That concludes the question. Yes, I will, on the test, definitely, I will tell you what to round to. Actually, this should be 3. So if I want to round it properly, I will write 0.0. Oh, the 7 is going to go to 9, so that's in a 10, so that's going to go to 6. That will be it, 0.06. Number 11, guys. A trucking firm. Probably you missed the Z test, so probably this is the Z test. A trucking firm suspects that the mean life of a certain tire it uses is less than 37,000 miles. To check the claim, the firm randomly selects and tests 46 of these tires and gets a mean life of 36,470. Assume that the population standard deviation is 1250 miles. At alpha equals 0.05, test the trucking firm's claim. I'm going to do this exercise both using the p-value and the critical value, just to remind you of the critical value. So HO and then HA, let's go there. And you guys agree with me, it says it suspects that the mean lifetime is less than 37,000. So that should be less than 37,000 miles here. And that would be mu greater than 37,000 miles or equal to. Let's see what we have. So they randomly select 46, so N is 46. They get a mean of 36,470. And they say the population standard deviation, sigma is 1250. And alpha is 0.05. So you guys, you should agree with me by now that this should be a Z test. All right. So if it is a Z test, let's run a Z test. I'll do it both ways, by the calculator, and I'm going to do critical values in a second. So you go to stats. Now a summary. I don't have, just data sets anymore. Mu0 is 37,000. Sigma is, what was sigma? 1250. X bar is 36,470. N is 46. And we're doing less than. There you go. Make sure to hit the enter when you select the alternative sign. Otherwise, it will not be selected properly. Calculate. Oops, let me see if I made a mistake somewhere. I got a strange number. Oh, I got 370,000 here, if you notice, guys. Once I got a strange value of the Z score, I realized something is not right. Clear? Now it's working. Watch. Can't get a Z of 1,000. That's not possible. Negative 2.88. So that's my Z. And my p-value is 0.0020. All right, so conclusion. This is less than alpha. We reject HO. And if we reject HO, we have enough evidence to support the claim. There is enough evidence at the 0.05 level of significance to support the claim that the mean life of a certain tire is less than 37,000. Certain tire is less than 37,000 miles. This is how you do it using p-value. Let me show you how you could have done that using critical values, guys. So I'm just gonna do it here. This is what you do. So critical value, you don't do the p-value, you just do the critical value. This is 0. Okay, first of all, you have to decide, is it a left tail test, a right tail test, or a two tail test? You look at the alternative hypothesis. Since it's less than, then it is a left tail test. So you shade a little bit of an area toward the left. And you put here a number which is called the critical value Z0, and I'm gonna show you how to find this number. Okay, here's how you find this number, guys. The area to the left of this number is always alpha, and alpha is given to be 5%. So you just put inverse norm, 0.05, and then comma 0, comma 1. If I do this one, that takes us back to the normal probability chapter. You go to inverse norm, 0.0501. I got negative 1.645. Okay, now we found the critical value. What do we do with it? Look what we do with it. You go to step 2, which is a negative 2.88. You could do that on the calculator by running the z-test, or you could do this, guys. X bar minus mean divided by sigma over square root of n, which is X bar is 36,470 minus mean 37,000 divided by 1250 over square root of 46. You will get negative 2.88. But let me show you how to make a decision. You know what this number is. This number separates the rejection region from the non-rejection region. So the one that's not shaded, it's where you don't reject HO, and the one that is shaded is where you reject HO. You place negative 2.88 on the number line. This is the number line, guys. Well, you would agree with me that negative 2.8 should be here because it's below negative 1.645. And since it's below negative 1.645, it turns out to be in the rejection region, so you reject HO. And that's how you make a decision. You see, it's the same thing. Reject HO, you get the same results. If you have a right tail test, guys, you can still use inverse norm 0.05, comma 0, comma 1, but you're going to get a negative number. All you need is just to get rid of the negative sign and put z equal 1.645. So you always can use alpha. The only difference is when you have a two-tailed test, you cannot use alpha. You have to divide it by 2. So you do inverse norm 0.05 divided by 2, comma 0, comma 1. This is when you do a z-test, when sigma is known. Now, when sigma is not known, you use, instead of inverse norm, you use inverse t. You provide the area to the left again, but instead of 0 and 1, you put degrees of freedom, which is the sample size minus 1. So this is how you find the critical value. let's go to the next exercise, number 12. That would be the last one. All right, guys. The National Center for Health Statistics report that systolic blood pressure for male 35 to 44 of age has a mean of 128. In a study of business executives, a random sample of 85 executives has a mean systolic blood pressure of 134. Do the data suggest that the mean systolic blood pressure for business executives is higher than 128? So the question is asking you if it is higher than 128. Assume that the population standard deviation is 10, use alpha equals 10%. So let's do this together. And I'm gonna do number 12 on a separate sheet of paper right here. So HO, he wants to check if the mean blood pressure of executive is higher than 128. So this is where the claim, guys. And this would be, so you need to read the question entirely to know where the claim is. It is greater than 128. He gives you N to be 85. He gives you X bar to be 134. Looks higher already. He gives you sigma population standard deviation, and he wants you to do it at alpha equals 10%. Okay, it's a z-test. Why z-test, guys? Because he gives you sigma population standard deviation, so we have to use the normal distribution, the z distribution. Okay, let's do that. So go to stat, z-test, stat, tests, z-test, mu zero. Mu zero is 128, sigma is 10, X bar is 134, N is 85, and we need to check the alternative sign, which is a greater than. So mu, you choose a greater than, and then hit calculate. Just make sure that my numbers, always double check, guys, your screen to make sure that your numbers are accurate. So I got Z to be 5.53, and the p-value is very small. You get the, don't forget the E-8, guys, don't ignore it. You get 1.589 E-8. A lot of students ignore that. Once you see the E, that means your p-value is almost zero. You can be safe and put almost zero if you don't know how to write it down. So it is zero actually, because I have to move it 8 digits. So just put 0.0000. So Z is 5.53. And p-value is 0.00, almost 0.00, which is definitely less than alpha. We reject HO. And we support the claim. There is enough evidence at the 0.10 level of significance to support the claim. The claim, okay, that mean systolic blood pressure. Why it is higher? Because they work under a lot of pressure managing employees. For business executives, is more than 128. Here you go. And that ends this problem. If you were, guys, to do this one by critical values, watch, I'm just gonna show you the last thing here. with a critical value, look what you do. It's a right tail test, so you shade to the right. This is your critical value right here. This is 0, so your critical value must be positive. Okay, look how do you do it here? You put inverse norm. Okay, I told you can use alpha, but alpha is going to give me a negative number here. So 0.10, which is alpha, comma 0, comma 1. Let me see what this number is going to be. Second distribute, inverse norm, 0.1, comma 0, paste. Okay, I got negative 1.28, but remember, this is a right tail test, so the negative 1.28 should be a 1.28. That's what your number is. Now bring the test statistic, which is 5.53. You guys should agree that it should be to the right of 1.28. So that means it falls in the rejection region, and then you end up rejecting HO. So this is how the critical value work. Any questions? So that is it. I'm not going to do anything else. You guys, you just do